Thank you. Two questions. Can you hear me? Yes. Can you all see down to the bottom of the white bit on the screens? Yes, good. So this is a talk, Advanced Python through Django. I'm going to be talking about metaclasses, which are an advanced feature of the Python language. But they're advanced in the sense that they perhaps come at the very end of a course about Python, rather than they're advanced because they're inherently difficult. Django makes extremely good use of metaclasses, and as this talk progresses, we're going to see some examples of how metaclasses get used and how they work. So the talk's really got two purposes, two aims. I want to explain what metaclasses are, how they work, and then to discuss what they're for and how Django uses them. Before we go much further, can you perhaps at the end give me some feedback? I always enjoy sort of being told after a talk what I could have done better or not at all. And obviously there'll be time for questions at the end. So we're using Django. We're using Django 1.4. I know this is a bit out of date, but there's a good reason for this, and we'll come to that towards the end. So I'd like to begin with a few examples from Django of how metaclasses are used. Metaclasses get involved when you create a class. So when you create certain classes in Django, a metaclass will do stuff. So let's see some examples of that. Now, my last client, I'm a freelancer, my last client was a farmer, and he had lots of ponies on his farm, and he wanted to track perhaps the name and the color and the birthday of each pony. So the obvious thing to do as a Django person is to create a form. This is a pony form class, and you'll see that I've given it three class attributes, which are fields. But if we examine this class, we'll see that it's got an extra attribute called base fields, which is a dictionary of all the fields on the class. Now, what's particularly interesting is that we didn't put this attribute there. It actually exists in the class's dictionary of attributes. We didn't put it there. It was put there by the class's metaclass. So that's our first example of a metaclass doing something perhaps unusual. So my client, he was pleased with this pony application. He asked if I could extend it to cover other four-legged farmyard animals like horses and donkeys. So I guess the obvious thing to do is to build a sort of an abstract base class to represent all our equine animals. So this was my first attempt. Unfortunately, you'll see that I've misspelled abstract. It says abstract, and when I try and create the class, I get a whole traceback and a type error down there. So this type error again has been raised by the class's metaclass. So this is just a second example of a metaclass getting involved doing something perhaps unusual. Third example, we eventually sorted out the abstract base class, and he wanted the client wanted a way to sort of categorize his ponies by the stable that they belong to, and you could say he was asking for a stable API. Thank you. So I put together a stable class. This is a stable model. And if I instantiate it and try and look up all the ponies that belong to it, well, this is going to fail, and we get an attribute error, because stables at this point don't know anything at all about ponies. But if we rewrite the pony class, if we give the pony model a foreign key to the stable model, then our existing instance of stable gets a pony set attribute, which is a related manager, which would then give us a way of looking up all the ponies belonging to that stable. So in this case, when we created the pony model, the pony class's Metaclass did some extra work, and it actually added an extra attribute into the dictionary of the stable class, as you can see somewhere down here, the pony set. Good. So those are just 3 examples that might whet your appetite. If you've not seen metaclasses before, you might be asking, where did these extra attributes, where did this extra behavior come from? If you have seen metaclasses before, perhaps you'd like to see how Django does it. By the way, if you're a Django core dev, this is probably not news to you, so you can go have a cigarette or sort of enjoy the green space to yourselves. Anyway, onwards. A very, very quick recap of what classes are and how they work. Here's a very basic definition of a class. It's got a name, some class. It inherits from object, so object is its base class. And then it's got a pair of class attributes. The first class attribute is obviously an attribute. The second is the under-init method. In Python, an object's methods are just attributes on the object's class, which happen to be functions. So what can we do with a class? Most importantly in Python, we can instantiate a class. So a class is like a factory for creating objects. So you instantiate a class by calling it. Here, instance is it's an instance of our class, and we can see that by calling type, passing in the instance. So in Python, if you've ever got an object and you want to know what it is, really you're asking what class is it, and type will tell you. So here, type is telling us that our instance is an instance of some class. Now, in Python, classes are just objects. So if you ask if a class is an object, you'll get back yes. So this means all sorts of different things, but in particular, it means that we can ask what class a class belongs to. So we can ask what class is some class, and we get back type. Now, the words type and class are more or less interchangeable in Python. So you can ask what class an object belongs to, or you can ask what type is it of, and that's really asking the same question. So we see that this class is of type. What that really also means is that it belongs to class. So something exciting that you might not have seen before is that we can create classes as we go. So we'd normally create classes by writing the class definition in a Python file. I'm going to wait for that to go overhead. Good. But also, given some certain information, we can create a class at runtime. And the information that we need to do that is the class's name, its base classes, and a dictionary of its class attributes. If we then call type again, passing in 3 arguments this time, so the name, the bases, and the attributes, that will create a class for us. You might want to know why this is useful. Sometimes you'll have some metadata that describes how a system should behave, and rather than hard coding that into your code, you can read that in at runtime and build up your classes and objects then. So you might not know in advance how your objects or your classes should behave, but by doing this, you can build up your classes dynamically. So I had a fizzy beer at lunch, which perhaps wasn't a good idea. Anyway, so I'd just like to demonstrate that calling type here has actually created a class. So first of all, we can inspect it in the console, and indeed, it looks like a class. We can check its type, and its type is type. So that's more evidence that we have actually created a class here. But more importantly, in Python, it's not what an object is, but what you can do with it that matters. And we can instantiate our example class, and we do end up with a real instance, of that class. So when you call type with 3 arguments, you do get back a real class. Now, we've seen 2 ways of creating classes. The kind of way that we're used to, where you put your code into a Python file, and Python loads it that way. Although we're more used to that, this second way is more fundamental, and actually the first way is just a kind of a syntactic sugar for this second way, where we call type. So this is quite exciting, because it means we can control how exactly classes are created. So you can imagine a function called createClass. You'd give it a name, some bases, and some attributes, and we can do absolutely anything in that function. We can change the name, we can change the bases, we can change the attributes. We can then call type with these 3 perhaps changed arguments, and we get back a class, and we've controlled exactly how that class will be created, and so how it behaves. So let's see an example of this. This is a function just about fits on the screen. It's called createFormClass, and you give it a name and a dictionary of attributes, and the function pulls out all the attributes which are fields, and it creates a new attribute called baseFields, whose value is this dictionary of fields. And then it calls type with the amended attributes. So this means we can call our function and put the return value in pony form. And then pony form, it's a class. But more importantly for this demonstration, it's got this attribute, baseFields, which is just a dictionary of all the forms fields. So you might see a parallel between that and the first example I showed earlier. Good. So we now need to ask and answer the question: what is type? So we've seen that we can call type with 3 arguments, and it gives us back a class. But what is it? So, as we said before, in Python, if you've got an object and you want to know what it is, really what you're asking is, what type is it? What class does it belong to? So we can call type, passing in type. Does anybody know what this is going to give back? Type. So if this is the first time you've seen this, this might be a bit puzzling, and you might sort of end up sort of asking how a thing can be its own type. But that's not really the right question to be asking right now. Really, what we should be asking is, what does this tell us about what we can do with type? So really, what it is telling us is that type itself is a class. So we saw earlier that anything with a type is just a normal class. And classes are factories for creating objects. We've seen that when you call type, you get back a class. So that must mean that type is a factory for creating classes. It's a class that creates classes, and so we call it a metaclass. Now, what's interesting about this is that because type is just a normal class, we can subclass it. So here's an example where we subclass type to produce a form, to produce a class that I'm calling formType. And we've overridden the under new method. So under new is it's a class method that gets called when you create an instance of the class, and it gets called before init. And its main job is to allocate the memory that the object that you're creating uses. But it can also be used to set up any aspect of the instance of the class that's immutable. And because classes are kind of immutable, overriding under new is the best place to sort of override how they're created. So again, here you'll see that I'm pulling out all of the attributes that we call taking a step back, we call under new with a class because it's a class method, and then the familiar name, bases, and attributes. We then pull out the fields of the attributes and bung those into a new attribute, as we've seen before. We then delegate to type, which is the superclass of our form type, and that will mean that we get a new class returned when we call under new. So if we've got a name and some bases, and again a dictionary of attributes, we can instantiate form type, and that will give us back a class which is which represents a pony form. In particular, we can check its base fields again, and indeed the base fields have been set up as expected. Now, in our Django code, we never actually instantiate a metaclass directly, and yet we still get all the useful behavior of metaclasses. So there must be a way that we can specify what metaclass to use when we create a class. Now, in fact, there's several different ways of doing this, but the most usual way, and the way that Django does in its source code, is to set a class attribute on a class called under metaclass. So here I've defined a class called form. Its under metaclass attribute is set to form type, and that tells Python when Python creates a form object, or indeed when Python creates any object whose class is a subclass of form, it should create that class. Sorry, that was wrong. That was wrong. It tells Python that when Python creates the form class, it should create the class with the form type metaclass. Similarly, when Python creates any subclass of form, it should use the same metaclass. So if we subclass form with our pony form, and we give it some class attributes, again, the form type metaclass is what will do the creation of this pony form class. And so we can see that the pony form has the form type as its metaclass, but more importantly, base fields again has been set up to be the a dictionary of the forms fields. And that's kind of it. That was a very sort of whistle-stop tour of how metaclasses work. If you've not seen them before, I should think you'll probably want to go over some of that again. There's a couple of good questions on Stack Overflow that explain in more detail how metaclasses work. And there's other sort of useful blog articles and things. So go and look those up. I'd now like to move on to talking about how Django makes use of them. So we can do a quick grep of the Django codebase, and we see that there are 5 examples where classes are given a metaclass. So in 2 cases, classes use media defining class as a metaclass. But by the way, you've all got the Django source code on your laptops, whether you know it or not, I guess. So it's worth sort of diving in and taking a look and trying to work out for yourself exactly what's going on in each of these cases. So for the model, for the media defining class, that simply adds an extra attribute or 2 onto the into the dictionary of it adds an extra attribute into the dictionary of the class that it creates. So it's nothing more exciting than anything we've seen so far. In a similar way, the declarative fields metaclass doesn't do much beyond adding the base fields attribute to the form class, and that's basically what we've seen so far. The model form metaclass is more interesting. So when you define a model form, you tell it what model it should be creating a form for, and the metaclass does all the work of actually creating a form. The most interesting and the most hairy, I suppose, is model base, which is a huge class of its own. This does all the work of verifying that when you create a model, you've defined it properly and that it is valid. It does all the work of setting up any relations with other models, and it does quite a bit more too. So rather than go through that in too much detail, I think you should go and inspect db models-base.py and try and work out for yourself what's going on there. Before we end, I'd like to talk briefly about Python 3. I mentioned at the start that we were using Django 1.4 for this talk. And the reason for that is that Django 1.5 supports both Python 2 and Python 3, and in Python 3 there's a slightly different syntax for defining metaclasses, or for specifying metaclasses. And so the way that Django deals with this in a single code base, the way that it deals with supporting both Python 2 and 3 is that it uses a library called 6, which has got a sort of a nice way of expressing a nice way of sort of specifying a metaclass without actually using either of the two syntaxes we've seen so far. So to get a sort of a different view on what metaclasses are doing, I'd suggest you go and take a look at 6 and see how it implements metaclasses. Other than that, in Python 3, metaclasses are a bit more powerful in that because they are known before the body of the class is read in, you can get your metaclass to provide a kind of a different object in which to put your class's attributes into. So rather than using a dictionary for the class attributes, you could say use an ordered dictionary, which would make certain things quite a bit neater, I guess. This isn't the first time today that people have talked about the Zen of Python. And I just want to bring out a couple of, almost bits, a couple of points. Simple is better than complex, and I guess we all know this, but I think we've also all got a tendency to try and show off how much we know or how many corner cases we understand, and that can often lead to code that's hard for other people to work with. I think when I put in my proposal for this talk, I was doing some work at a company who I think had probably overused metaclasses a bit, and that led to code that was fairly difficult to understand. So I'm not saying that you shouldn't use metaclasses at all, but I think you should use Django as a good model for how you should. So in Django, the metaclasses are all sort of out of the way, and as a user, you don't see what they're doing sort of most of the time. But they're there to make your life as a user of Django much easier. Of all the 3 examples, and in fact, I think probably everything that Django does with metaclasses, you could do without, but it would require more work and more effort on behalf of the user. I'd also like to say that the first point, beautiful is better than ugly. I think that also applies to metaclasses. I think there is something really quite satisfying about how classes are just Python objects and how they're created by other classes. And I think there is something sort of almost beautiful about how Python does that. So I guess that's it really. Just a couple of key things to take away. First of all, classes are just factories for creating objects. Metaclasses, they're factories for creating classes. and metaclasses allow us to control exactly what happens when we create a class. So thank you, I think. Any questions or feedback?